Hello children, I am Bindu. Today we are going to learn the chapter Force and Pressure of Physical Science of Class 8. As we completed the types of force in previous, first we shall revise the previous lesson. Recapitulation. Force is a push or a pull. A force can act on an object with or without being in contact with it. A force acting on a body is either a contact force or force acting at a distance. Field is a region in which an object kept at a point in the region is influenced by it. Friction is the force that opposes relative motion of surfaces in contact. The force which we exert by using our body muscles is known as muscular force. The attractive force between any two massive objects is called gravitational force. The force exerted by a magnet on another magnet is called magnetic force. The magnetic force also acts on magnetic material such as iron. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. Learning objective. Balanced and unbalanced force, net force, addition of force, calculation of force of a free body diagram. Effect of force, application of effect of force. Keywords of the lesson. Force, net force, magnitude, state of motion, pressure, area, free body diagram. This is the mind map of force. Balanced and unbalanced force. Hey, you can see here. Children are playing tug of war, pull the rope in their respective directions. If the pull of the force is equal on the two sides, the rope does not move. This means that initially the two forces are balanced. Now you can see boys on the left side has won the game. means that more force has been applied towards left side. If the force is more on the one side, the rope moves in that direction. The rope moves in the direction of higher force when the forces become unbalanced. Now, we are going to learn net force. In reality, many forces can act simultaneously on a body or any object. Children, look, there is a car on the road which is not moving. There is existence of two forces on an object placed on a horizontal floor. One is gravitational force, vertically down, and the other is normal force, vertically up. There is no change in the state of rest of car because of this force. Because two forces acting on the object are equal and opposite in direction. Hence, there is no change in its state. Same forces are applicable not only on this car but also every object around us. All forces have both magnitude and direction. While adding forces, the directions of forces have to be taken into account. To add forces, sign convention must be used. Look at the screen. Here, two men are pushing a table in same direction with same force F1 of each. So, in this case, both of the force applied by two men will be added and net force is 2F1. When forces act on a body along a straight line and they are in the same direction, the net force is taken as the sum or resultant of all forces acting on the body. When two boys push the table from opposite sides, the table doesn't move if they both apply force with equal magnitude. When two boys push the table from opposite sides with the forces F1 and F2 respectively, the force F1 directed towards right could be taken as positive. And the force F2 acting towards left could be taken as negative. As the forces F1 and F2 act on the table in opposite directions as shown in the picture and assume F1 is greater than F2. Then F net is equal to F1 plus minus F2, as F2 is opposite to F1, is equal to F1 minus F2. When the forces on the body in a straight line are in the opposite directions, the net force is equal to difference between the two forces. The object at rest moves in the direction of the net force acting on it. Now, we shall learn how to calculate net force of a free body. But what is a free body? All the forces acting on an object at a particular instant is called free body diagram. Let's take an example like a car be moving with a non-uniform speed along a road. What are the forces acting on the car? What is the net force acting along the vertical direction? What is the net force acting along the horizontal direction? You can see on the screen a coordinate system with x and y axis. All the relevant forces acting on the car are capital F is equal to force applied by engine along with x-axis. Small f is equal to friction applied by the road along with x-axis. N is equal to normal force along with y-axis. Resultant normal force applied by wheels. W is equal to gravitational force along with y-axis. Sign convention is to be taken along x and y directions. Now, we have to add forces algebraically with sign conventions along x and y-axis separately. Net force along x direction F net x is equal to capital F minus small f. Net force along y direction F net y is equal to N minus W. There are two effects of force. Force can affect the state of an object and direction of an object. Let's take an example of bicycler. Force applied on a cycle may change its speed. If the cycle is in the direction of its motion, the speed of the cycle increases. If the force is applied in the direction opposite to the direction of the motion, then it results in a decrease in the speed of the cycle. Force can change the shape of an object. It may change the shape temporarily or permanently based on the nature of the object and the force applied on it. Before starting the next topic, can you answer me that are force and pressure same? The force acting on a unit area of a surface is called pressure. Children, to understand the effect of force, we shall do a very easy activity. Look, we are taking 2 trays filled with lime powder on fine sand. Now, we are taking 2 rectangular bricks of equal mass and similar shape. One brick is kept vertically in one tray and the other brick is kept horizontally in the second tray. Here you can notice that the brick standing vertically sinks deeper in the lime powder than the brick standing horizontally. Since the masses of both bricks are similar, the force applied on lime powder by them is the same on the both trays. The difference lies in the surface area of the brick in contact with the lime powder, and this is responsible for the change in the extent to which the brick sinks in the lime powder. In this activity, the contact area on which the force is acting is different in each case. The depth to which the brick sinks in the first tray, A, is deeper than in the second tray, B. This is because in tray A, the contact area or the surface area on which force is acting is smaller, and hence the pressure exerted by the brick is more. In tray B, the contact area or the surface area on which force acting is larger. Hence, the pressure exerted by the brick is less. Summary of the lesson. Force has magnitude as well as direction. The algebraic sum of all the forces acting on a body is known as net force and is denoted by F net. A force can change the state of motion of an object. Force may cause a change in the shape of an object. A force acting on a unit area of a surface is called pressure.